Lesson 2.2 is modeling with power functions. Basically, learning what a power function is, what is a power function, what isn't a power function, everything that goes along with power functions. Now, the big thing to keep separated, and we'll talk about down at the bottom of the notes. What we've been talking about lately have been polynomials. Okay? And polynomials, and you'll notice the very bottom thing it talks about is what is a monomial function, which is just one piece of a polynomial. Monomial and functions and power functions are very, very similar, but they're just slight differences. Okay, so monomial are the ones we've talked about. We're used to seeing them with positive whole number exponents. Okay, and that's the big thing there. Power function is a little bit different. Okay, so definition of a power function. Okay, so power function, they give it as the format f of x, which is the same as y, right? Equals k times x to the a. And you'll notice there, pay attention to everything it talks about. K and a are constants, but they're non-zero. If they become zero, we have a problem here. Okay? A is considered the power. So if you're asked for a power, K is what we call the constant of variation or proportion. I don't know how much you guys remember about direct variation, inverse variation. It's not in the standards as much as it used to be, so we don't teach it as much as we used to. But K is your constant of variation or proportion. Okay? In terms of a power function, it is normal to see the vocabulary f of x varies as the 8th power of x. I'm not saying 8, I'm saying a, though. I don't know how to differentiate that one. I've never been able to figure that out. But the a power of x, or f of x is proportional to the a power of x. Okay, those are, good vocabulary terms there. As always, the independent variable is x. Majority of what we do, independent variable is x, because x is your horizontal axis, right? And y depends on x. So most of what we do, x is your independent variable, y depends on it, so y is our dependent variable. I mentioned direct and inverse variation here. So power functions with positive powers are statements of direct variation. They state it here as f of x equals k to the x. I don't know that we talked about it in Algebra 2, but if you remember it from Algebra 1, y equals k to the x. Okay, that is your typical direct variation setup. Notice k is your constant of proportion. And then if a power function has a negative power, well, that's the format of inverse variation. And how do we get rid of a negative power? To get rid of a negative power and write something, we move it to the denominator, yes? That should sound familiar. And so f of x equals k over x, or in other words, y equals k over x. Okay? So that is just kind of your basic information. When we get to example 2, we'll go through and really zone in on what is and is not a power function. But for example 1, they're going to ask us to write one. Okay? From empirical evidence and the laws of physics, it has been found that the period of time t for the full swing of a pendulum varies directly as the square root of the pendulum's length L, provided that the swing is small relative to the length of the pendulum. We're going to go back and break it down here in a moment, okay? Express this relationship as a power function, okay? So my goal, basically, what they're saying is write this as a function, write it as an equation, and it's a power function, okay? So from the empirical evidence and laws of physics, it has been found that the period of time, and what do they tell us to use? Capital T, for the full swing of a pendulum does what? Varies how? Directly. I said that was that's a key phrase, right? Varies directly or varies proportionally. And what does it vary directly? As the square root of the pendulum's length, which what do they tell us to use? L. Okay. Provided that the swing is small relative to the length of the pendulum. Okay. Did you gather a little bit of information that time that breaks it down for you?
Yeah.
Okay. When I teach direct and inverse variation, I always think of this as when it's like y equals kx, this is y varies directly with x, is what I think of this as. So if you hear y varies directly with x, what do you have to throw in? You have to throw in that constant, okay, that k value, that constant of proportion of, or constant of variation. If you hear y varies inversely with x, again, you have to throw in that constant value. They're not going to necessarily tell you that, okay? So that varies directly statement is what's doing this. So, okay, go back to what I circled. What do we have? Time varies directly as the square root of the length L. Okay, that's what I need you to focus on. So what's my equation going to start with? Go with what they give us. They give us t, yes? I'm not against f of x, but if they give you specific variables, you need to use those. Fair enough? If they don't give you a variable, then by all means, you can define them as you want. So, time varies directly. So varies directly tells me I'm going to go for this format here, right? And this format is y varies directly with x. So varies directly to me says I'm going to say equals. Varies directly means there's going to be some constant. So I'm going to use k times. What are we varying directly with?
Length.
There's a slight catch here, but yes, length. The square root of length. Okay, so if it just said time varies directly with length, then I would say L. I don't want to make my L. I'm trying to decide if I want to use a cursive. I feel like I usually use a cursive there. Now, but it didn't just say it varies directly with the length. It says it varies directly with the square root of the length. So now I'm going to say square root of L. Okay, did I break that down a little bit for you? Now, I would argue we need to tweak one little thing to write our final answer, but we've pretty much got to have our final answer here. Okay, we don't have to do anything with it. They just asked us to express this as a power function. If it's a power function, go back to this format up here. What's slightly different in ours that we could change?
Can you do like bro? Can you do like T of L? Is it the fact that we have a square root and they have like an actual power?
The issue I want to talk about is the square root as opposed to a power. Okay? And I'm not, here's the deal. They gave me T and L, so what needs to stick in my answer? T and L. Now, I do agree with whoever said I'm not going to, but technically this is the function T in terms of L. Could you do that? Yes. I'm going to say it's not necessary though. Okay? What I'm looking at is, what about square root of L? That is L to what power? Remember, a square root has a root of 2, and that's your denominator, so this is L to the 1/2 power. If this is a power function, it's something that can be written in the form where it's x to a power. Are we at x to a power now?
Mm-hmm.
Yeah. So I would say to rewrite this as T equals k times L to the 1/2. Where k is a constant, and then it's L to the 1/2. Because the only restriction on the exponent was that it's a non-zero constant. That's the only restriction on the exponent there, is it can't be 0. So that means it could be a whole number, it could be a fraction, it could be a decimal, it could be positive, it could be negative. It just can't be 0. Okay? Okay, what other questions do I need to answer on this one? We good? Maybe? Okay. if I recall correctly, I think you have to write a few in homework. So I'm recalling the correct homework. Okay, start looking at example 2. Yeah, you have to write a few. Okay. States the power and constant of variation for the following power functions. So, what form is this based on then? If you look up above, this is based on the form f of x equals k x to the a, yes? Just a little reminder, that's the form that they told us. That's what a power function looks like. Where k is your constant of variation, a is your power. So, on example A, f of x equals the cube root of x. What should we probably start off thinking about? What about the power? No? So I would encourage you, I'm going to rewrite this as this is the same thing as saying f of x equals x to the 1/3. Okay? With that in mind, what is my power? My power is 1/3. Now, in terms of what it is in the equation, I'm going to say that my power, I'm going to use that as a because I don't want to keep writing the word power every time. A is 1/3. Or you can write power. I guess in the homework answer key, I just wrote power every time. I typed it actually. Okay, what else do we need to know? Thoughts on the constant of variation? No? No? 1. Remember, the constant is k. It is a non-zero constant. So it has to be a number, no variables allowed. Non-zero is the requirement. So it is your k, so I'm going to define this as k equals 1. And I'm just going to use a and k across my screen now because I don't want to keep writing those words. And in reality, I've got to watch my time too. I'm fine on time, but you know. Okay, are we good? Okay, let's try B. G of x equals 2 over x squared. Thoughts?
That's the power 2.
Nope. What'd you say?
-2.
I can get behind -2.
Because it's on the bottom, do they have to flip it?
Yeah, so here's the deal. In its given form, does it match our provided form up top? No. Make your first job to match that provided form. Number times x to some power. Right now I have number divided by x to some power. That's not what I need. So I'm going to rewrite this as g of x equals 2 times x to the -2. Because to move an exponent across the fraction bar, we change the sign, yes? So now, what did you think the power is? -2. I can get behind that. What is my constant of variation? 2. Okay? C. H of x equals -x to the -4/10.
Would your power be -0.4?
Are you guys good with that? There's not a trick here necessarily in this one, is there? Other than, well, I'll talk about here in the end. So my power, my a value is -4/10. What else?
Is it your constant of variation -1?
Constant of variation is the invisible -1 out front, yes? Okay. Now, it seems pretty straightforward, and it is, but here's the deal. That is an example of a power function. It is not, and I'll talk about this down below, not an example of a monomial or polynomial, because in a monomial or polynomial, you don't get decimals in the exponents. And in fact, none of these would be monomials or polynomials, because you can't have a fraction in the exponent. You can't have a negative in the exponent. You can't have a negative or a decimal in the exponent. Okay? Okay, D, m of x equals -3.
Would that A be 0?
Okay?
Or,
But A can't be 0.
or it could be no solution?
So if we rewrite this to try and get this in the correct form, can we agree that this would be -3 times x to 0?
Yeah.
Agree that that's equivalent, yes? So what do we want to say the power is?
0.
We want to say the power is 0. But what's the catch?
We don't have X.
K and A are non-zero constants. What's the only thing that K and A can't be?
0.
0. So what do I know about this?
No solution.
It is not a what? What are these all supposed to be?
Function?
Constant variation.
Power function. So this is not a power function because A is 0, but A can't be 0. Okay, so I forgot to write A equals 0 there because that's the problem. A can't be 0. Okay? So watch out for, you're going to have some homework where they want you to go through and identify, kind of like what we did here, what's the power, what's the constant. Are they going to throw some in on you that aren't power functions? Yes, they are. Beware. Okay? Are we good? Okay. Now, I referenced this already some, but the bottom piece of this, it says definition of a monomial function. Now, keep in mind, monomial is just a small portion of a polynomial, right? Like binomial, trinomial, multiple terms added or subtracted. Now, the catch here, monomial could either be f of x equals k, or f of x equals k times x to the n. Okay, so they still use k, but they use an n instead. And this is a monomial function, and they give us those two options. But what's the rest of the definition say? K is a constant. Does it define what type of constant?
No.
No, K is a constant. No rules. It's a constant. And n is a positive integer, or how I often say, a positive whole number. Okay? So, which, that's kind of a little duplicated there, because by definition, whole numbers are positive, but if I say positive whole numbers, I'm reminding you that whole numbers are positive. So for instance, positive integers are going to include numbers like 0, 1, 2, 3, so on and so forth. Notice, whole numbers do include 0. Okay? So those are your differences there. Now, we just have a very basic example here on example 3. They ask us to state the degree, the coefficient, and the independent variable of the monomial function y equals -3 x to the 5th. Do you remember the vocab degree? What's my degree here? 5, because your degree is the power, yes? If it's a polynomial, you're looking for the term with the highest power. But in this case, your degree is 5. Or in other words, where does it come from? It's your n value, right? Coefficient.
-3.
Coefficient is -3. It is the number out in front of the variable portion, yes? Okay, it's also, in this case, and based on definition, it's our K value. And then, what is the independent variable? Do we know? I mentioned it earlier.
X.
Independent variable is X. Okay, X is kind of the idea of X is what you plug in for, Y is the outcome. That's the independent variable. So, those right there. Okay, guys, your homework is doing this basic type of stuff. You're going to have to think a little bit on homework, but it goes pretty quickly. You have a section in homework. I'm trying to remember. The first section starts off kind of like our middle section. 1 through 10 is determine if it's a power function, given, and they tell you some certain variables that are constant. And then if it's a power function, state the power and constant. 11 through 16, is it a monomial function? So then using those rules. And 17 through 22, they want you to write a power function. Okay? So, what I will caution you on is in the first couple of sets of directions, it tells you that, for instance, C, G, and K, and pi are constants. Well, hopefully you know pi is a constant. Pi is a number, right? But it also tells you that for this particular set of examples, C, G, and K are constants, which means they represent numbers, but they are not variables. Okay, so that's something you have to think through. And I'm sure we'll talk about it on Monday.
I guess they were on